Hello everybody, this video presents you 6 challenges to solve. You don't need any knowledge on programming, all you need some problem solving skills. Here we give you a very simple device which can do the following 5 instructions. Firstly, it can check if x is equals 0, then move to a particular instruction line. What does it mean here is x refer a placeholder which can hold some values. You can imagine x would be a bin jar, a jar which can hold some beans in it. Okay, we can give a name, call it x. Then this instruction will check if your container is empty or not. If it's not empty, it will go run the following instruction. So carry on. Otherwise, you will move to line L. As simple as that. That is what this instruction means. And second one and third one, you can see it's perform simple counting up or counting down. So minus 1 means just remove one value. And if you do minus 1 again and remove another one, okay, then plus 1 equivalent, we get another bin, it's called bin, and drop it in the jar. So that is add 1 value to the current container. Then the fourth instruction is about control your instruction flow. Normally instruction will go 1, 1, 1, you follow your instructions. But then all of a sudden you don't want to carry on, you might want to jump to somewhere else. You can say go to number 3, for example, if that's the 1, 2, 3, that will jump to there instead of going down the next line. That will help you to create kind of a loop or some other purpose. Right, so finally, this is nothing like instruction. It's rather just making a statement saying, here is place you stop. Computation finished. Okay, that's whole 5 things this device can do. The hardware, at the hardware level, we can only achieve these 5 things. Okay, one thing we need to mention is there are actually unlimited memory spaces. In order to refer which memory space you're talking about, we use letters to name each container, X, Y, Z, etc., etc. So when we say instruction like this, you don't necessary to you always use X. You can just literally say if say you use Y equals 0, and go to line 10. You can name your memory with any name, temp, ABC, anything. Now let me give you an example. Suppose we want to have a new instruction to do set container X to value 0, which is equivalent, and here is our jar X, and initially have some random number of bins in it. Now I want to set this jar to empty. So set X to 0, which means remove all those bins. Look at the instruction we gave you so far. In 5 instructions, we don't have such thing to set a particular memory space to 0. So we have to implement it ourselves. How can we do that? The idea is we can test if it's empty, right? So you can create a loop from any arbitrary number. We don't know how many bins in X. You can keep doing minus itself by 1 until it reaches 0. Then you achieve this function. Okay, so let's just write. First line is we check if X is empty or not. Okay, so if it's empty, so really we should finish. So go to a particular line, don't know which line yet, so I temporarily leave it a question mark. Let's call it line 1, line 2. You do take one value out from x, yeah? So take one out and assign it back, which means subtract by 1. And then I want to create a loop to repeat this. So here I will say go to line 1, right? So that will be a loop from here, check there. So we check if it's 0, and if it's 0, it should stop. Let's call this line 4. So go to line 4, and line 4 is stop. These 4 lines of code implemented this function, set value x to 0. Now we have implemented new instruction, which is called set x to value 0. So we can add this as our new instruction extended. This is our extended instruction set. Once you implement it, you are allowed to use it. I'm going to show you our challenge. We have a 6 tasks to do. The first task is copy y to x. If you write down as normal, language fashion is just writing x equal y, set y's value into x. So how can we go about to do this? First, you need to clear x. Yeah, initial value in x is not going to be relevant at all. This can be achieved by the instruction we just implemented previously. We can just do set x to 0. Then second phase is do copying. At the moment, hardware can only do +1, -1. You can create a loop doing taking value. This is value, taking value out from y, 1 by 1, and at the same time adding that value, adding that bin, take out from y, adding this to x, and then create a loop. You can loop it until y is empty. Here we should go to the end of code, probably it's line 5. Let's just call it 1, 2, 3, and that's a 4. Go to 1. Okay, so that's it. This loop will keep moving bins, moving values from y to x. Be careful, first of all, we already set x to 0, right? So you keep doing this, and when you reach the next step here, then you know, when we come here, all bins in y are in x. Now we have a problem with this solution, which is after we're doing this loop, y will be nothing left. Okay, so at the end, y left nothing, which is not what we wanted. We already said the contents of y should be unchanged here. So this is a challenge for you to do. You have to think a way to create another copy. Basically, we need 2 copies of the y's. I gave you a hint. We need third container. We need another variable. Okay, a third container is needed to help us to create an actual copy. So good luck. This is our first task. Our second task is to add y to x. That is x equals x plus y. As a matter of fact, the difference between x equal y and x equal x plus y is very little. Let me explain why. This is our grx, gry. When you do copy, initially you have some bins, you have some values in x and some values in y, right? So what we do is we have to remove all the value in x. After we remove them, we do the copy. We copy value one by one. So two steps. One is clear x. One is copy. What's difference here? When you do add, we have x, we have y. What value initially you got here must be kept because you're going to topping up, okay? So that is what you have in jar Then after addition, after performing x equal plus y, you really need to have that amount where the bins all topped up, right? So that is y. What's value y? That is what value x. Therefore, you add them together. That is x plus y. No need to clear x. I shouldn't say no need. It's you must keep. Yeah, I should say precisely. You must keep initial value of x. In summary, if you can do copy, then you can do plus easily, simply removing this operation. That will give you addition. Now let's add two functions we implemented to here in our box. In the following tasks, you can make use of all of those. Our third task is to work out the difference between x and y, which is actually performing a subtraction. ABS means absolute value. Absolute value means when it is negative, we simply remove that negative sign and turn it to positive. If it's positive, we just keep it unchanged. The reason we do it this way is at the moment we simplified our model. We assume that our hardware doesn't deal with a negative number. So all the value in here we're talking about a positive value. If you already have x equals 0, if you force the machine to do x equals x minus 1, that won't work. It won't go down to minus 1. That will still produce x equals 0. So that is our current assumption. So we don't have a concept of a negative number. That's why when we deal with subtraction, we use this absolute value to get around negative numbers. Now I'm going to explain the basic algorithm for working out this. Still using a bin jar. I really think the bin jar is a good idea because we're working out calculation one by one by plus or minus 1. So it's really thinking about each individual bin you want to move in and move out. Let's say this is jar X, this is jar Y. Initially they have some bins. Okay. Based on what we got, instruction is we can do x equal x minus 1, can do y equal y minus 1. If we reduce the number of bins in both jars in same speed, which means create a loop. We do this, two operations together. Yeah, so we loop on this. Both jars will reduce the bins in each loop. So no matter who reaches the empty state, the remaining bins in another jar will be the difference between them. That is a key idea. You just need to implement it, to use our instruction set to create a loop, repeatedly doing this. And each time after you deduct a value, you need to check who ended to an empty jar. There will be three cases. One is when x equals y. Yeah, the difference between them is 0. Okay, and then second case could be when x greater than y, and then when x less than y. So three situations you need to handle. From task 3, we didn't mention that you have to keep y and x, the value unchanged. The reason for that is because we already implement copy. Once you can do copy, that is no longer an issue. Okay, so when you work out task 3, you don't have to worry about keeping y and x unchanged, because we know we can always pre-copy it, then we can copy it back. Task 4 is very similar to previous tasks. It asks you to compare two values in x and y, and based on if x is greater than y, that condition hold, we go to one instruction line. Otherwise, we go to another place. As you can see, we are really doing same process as we do in task 3. We have x here and y here. You just need to compare two containers, yeah? You just need to go same process, reduce their value one by one, and see who reaches 0 first. The value reaches 0 first means it's a smaller value. Okay, and if it's smaller, you end it access level, you just say go to, you simply just say maybe go to L1. And somewhere you just say go to, in the case when x is greater than y, you go to L1. Otherwise, you just say go to L2. It's different way to end the program, but the basic principle is same thing. We apply same idea. Have a loop onto two jars, and do the subtract by 1 together. It's really similar program structure. Okay, next one. We are doing multiplication. We already implemented x equals x plus y, which is addition. This challenge is to implement multiplication by repeated addition. We all know that when we say 5 times 3, that means you have 5 of 3s. So 5 times 3 equals 3 plus 3 plus 3 plus 3 plus 3. 5 times. All you need to do is create a loop. I leave this for you to sort it out. Finally, we are going to deal with division. Okay, division is the inverse operation for multiplication, and also division can be done by continuous subtraction to work out. Let's assume x is 10, y is 3. So when you perform x divided by y, what you can do is you can start from 10. 10, you have a counter C, start from nothing. We want to count how many 3s are in 10, so we just do 10 minus 3. It's kind of a loop, yeah? Equal 7. And then the counter will be plus 1. So, okay, I have 1 3 in it. So now C is 1. And then it's just continually doing subtraction. So 7 take away by 3 is 4. And the counter plus by 1, yeah? So counter is 2. So now 4 take away by 3. Now it's 1. My counter moved up to 3. Now, in the end, when we find the condition, the really need condition, as previously we implemented, if we find this value 1, 1, 1 is already less than 3, we really should stop. We stop when this condition hold. You can't do the subtraction anymore. So final value left here is the remainder. So in this case, x is 3, yeah? X divided by 3 is 3, and the remainder, you should somehow put remainder into z. Okay, so that is about division. If you successfully finish all the tasks, you can convince yourself that you have using software, which is assembler code, to build up arithmetic unit. The hardware of that computer actually is only a counter. It can only do count up and counting down. And with a very simple control facility, which is checking if x equals 0. That is our simplest computation model, which is equivalent to Turing machine. Good luck.